So question 19 is similar to this question, which I've created just to show you the general principles in question 19, and then you could complete question 19 and see if you get it right. So this is just mimicking question 19 from test 10, section 5. So this question says, let the function f be defined by f of x equals 3x minus 1. So remember, f of x is just a fancy way to say y when given a particular x value. Okay, so the second part of the problem says, if 1/2 f of the square root of t equals 6, what is the value of t? So we know that our x value here is square root of t, and then all we have to do is plug in square root of t where we see x here. And then we fill in the other information that we have for this problem. So let's plug in what we have. So 1/2, and f of square root of t is going to be just a matter of plugging in square root of t as x here. So this is 3 times square root of t minus 1. And this is all set equal to 6. Okay, next we can multiply by 2 on both sides to get rid of this 1/2 here. So then we have 3 times square root of t minus 1 equals 12. Then we can move this 1 over here. We're just combining like terms. This is going to be a pretty ugly answer. I wish I'd come up with a slightly better answer or set of numbers for this. And now we could divide by 3 on both sides to get root t alone. So then we get root t equals 13/3. Now we want to know the value of t, so we need to square both sides. And it's a little tricky when you're squaring a fraction. This needs to get distributed to the top and to the bottom. So 13 times 13, just gonna double check. Ideally, it would be ideal if you could memorize all of these perfect squares. So it's 169, and 3 squared is 9. So if this was a grid-in, since you can't grid this in as it is, you just want to see if you could divide by a common factor for either of these. So let's see if we could divide by a common factor. It looks like we probably can't, because 9's factors are 1, 9, and then 3. And I tested out 3, that doesn't work. 9 doesn't divide evenly into 169. So if this was a grid-in, you'd know your answer was wrong, but this is the right answer for this particular problem. Your answer for number 19 will be a little bit nicer looking than this particular answer, but these are the general principles for this problem.